should be coming by me. Okay, so on page 246, number 16, we have this chart. Okay, and it says, think about a plan. The data shows the power generated by a wind turbine. The X column gives the wind speed per second. So this column is wind speed per second. Okay, who knows what a wind turbine is? Tyler, what's a wind turbine? Oh yeah. Okay. I guess like seen a windmill. Yeah, especially in the mouth of one of those canyons. Not Big Cottonwood, but a little further south. There's those, and actually even at the point of the mountain, right? There's those big white windmills. That what they do is they collect wind energy and turn it into usable energy. Okay, on the y-axis it says, let's see, it's the power generated in kilowatts. So the faster the wind is, the more power that's generated. Power in kilowatts. So that's in your book. So here's the question. What is the degree of the polynomial function that models this data? Okay, so whenever we plug in an x, we have to get a y that follows this pattern. So if we plug in 5, how does 5 become 10? What are some possibilities? How does 5 become 10? We could add 5. 5 plus 5. Now let's see if that works. It's going to be x plus 5. If x is now 6, is 6 plus 5 17.28? No. So this is linear, because this would be x to the first power. There's another linear function I can think of. That how does 5 also become 10 besides adding? Times by 2. Let's see if that one works. Okay. What about 6 times 2? Is that 17.28? No. Okay. So unfortunately, this polynomial is not an easy one because it's not linear. So it actually gives you some hints in the book. There's 3 bullet points that teach you how to do it. What are the first differences of the y values? Remember at the beginning of class, last time, we had a pattern that we looked at the differences. You guys remember that? Yes. Okay. How did we do it? Did we do 10 minus 17.28? Did we do the top one minus the bottom one? Bottom minus the top, because if we do top minus bottom, we're getting a negative number. Okay, so we need to know what 17.28 minus 10 is. What's that? 7.28. Okay. If you have calculators, we're going to need them because of the decimals. They're going to get a little crazy pretty quick. Okay, 27.44 minus 17.28. So this next difference. That's why the activity last time was called What's the Difference? Because difference means subtraction. 10.16. Squeeze in the 1. Okay, and then we have 40.96 minus 27.44. 13.52. Good, Arbor, did you do all of this already? Yeah. Good, so we can give quick answers. 58.32 minus 40.96. Arbor, what's that? 17.36. Good. Any questions how we're getting these numbers? Okay, now I'm going to ask Arbor to not give us the next answers because it says, what are the second differences? So we do it again. Okay, so everyone else, pull out your calculators and let's do this. What's 10.16 minus 7.28? Who has it? Okay. 2.88. Alright. And the next one? Raise your hand when you get it, please. Okay, now there's more people out there with calculators. What is it, Nico?
8.36.
Oh, I plus them. Yeah, that sounds right. Okay, thank you. And the last one here. The last one, Amy? 3.84. Great, thank you. Now it says, when are the differences constant? Are these constant? What does it mean to be constant? Yes? Gucci? What does it mean to be constant? To be the same. Okay, so these don't match yet, so we're going to keep going until they're the same. So let's try another one. Okay, two more there. Gentry, do you have a calculator? Who else? You haven't given me an answer yet. Silver, can you get this one? 0.48. And the last one? Arbor?
0.48.
Oh, are these constant now?
Yeah.
Good. So they can tell us the degree, because this row, if this was our starting polynomial, it would be constant. Then it starts to vary, so we added one variable, which makes it linear. If the power is x to the first power, it's linear. If we go one more degree, what's x squared called? Good. Quadratic. If we go one more power, what's x to the fourth called? X to the third, yes, cubic. Sorry, I said fourth, I meant third. So there's our answer. This is cubic polynomial, so the degree is 3. Does that make sense? You can break it down until it's constant, and then you can count back and see what the degree was. Okay. All right, trade with the neighbor, please. You should still have the red pens. And correct right in the book. Just bring it up really quick. Put corrected by on the book.